Hello everybody. Can everybody hear me? And see my screen preferably? Okay. I'm currently working from one screen, so I hope it works fine. So let's get started. My name is Mulkens. Normally I do this presentation with a colleague of mine, Kimberly Hermans. You can see on the slide my blog and both our Twitter accounts. Do follow us. The slide deck is one from the Power BI event that Chance Therapy organized in London. So that's that explains the sponsor slide. My name, as I said, is Jan Mulkens. I'm a Microsoft BI consultant at Ordina, Belgium. I have some certificates in Microsoft technology. In my day-to-day job, I do almost everything from setting up a data warehouse, DTL, up to creating reports together with end users. Kimberly, who won't be joining us today, I will still be giving her a lot of credit because without her, the session wouldn't have been possible. She's a data scientist at Ordina, Belgium. And well, that's not about everything I can say about her. The agenda for today will include a short introduction. We'll go over corporate BI and corporate data science solutions and what the goals really are for them. Next, we'll discuss the personal BI and personal data science goals and solutions. And lastly, we'll have a short look at how you can apply Power BI in your organization for creating more of a personal data science environment. So we start off with the statement that I came up with a couple of months ago. It is a Power BI can not only be used to democratize BI across the enterprise, but it should also be possible to democratize data science across the enterprise. After I thought of this, because I thought of this while working on a Kaggle competition, I went to search for a data science scientist at Ordina who could possibly help me set up a presentation to use Power BI for this. Kimberly was nice enough to believe in me and help me with that. And this brings us to basically why this presentation, why you should follow this presentation. So next slide. In 2012, Gartner published this picture stating that you go from descriptive analytics through diagnostic up to prescriptive analytics in an organization. But the focus on this graph lies not on how you do it or what you should do it, but the focus here lies on, well, to go from basic descriptive analytics, creating your regular reports, it becomes more and more difficult to go to an analytics environment that can predict things. And as it gets harder, obviously it gets more expensive as well. Most people who work with a BI environment or who pay the bills for those environments, they know this. They already well, they already pay for at least a descriptive or at least a diagnostic analytics environment. So in 2014, Gartner published a different view of this graph. And something this graph is something that has been used and used again by Microsoft at the very least. I've seen it pop up on other blogs and other sites as well. Basically, what it states is that you don't focus on the difficulty, on the cost of these solutions, but you focus on what value do they bring to your organization, and you focus on the fact that you need to go from data, pure data, up to a decision and even an action. So most BI environments, as you know, they start at static reports and interactive dashboards. When you have a static report or even an interactive dashboard, there's this manual process that still needs to be taken to go to a decision. So say you have a report that states that business went bad. Well, that means that you still need to do some analysis, you still need to talk to people before making a decision. And after having made a decision, you need to take action, so a corrective action for your business. This is what a traditional BI environment is. Most of the people, I suppose, already know this. But when we go beyond this, we go into data science territory. We see that we can predict, we can make predictions with the data that we have. And when we can predict the outcome of certain things in our business, like when will this machine fail, the decision that we need to make, we have a very small manual process to undertake for that. And that brings us closer to the action as well. But more advanced data science projects, they even bring us a decision up to our porch. They say, well, these are your decisions that you can make based on the data that we have and based on the previous data that we had in the past and the decisions that were made then, or some business rules that were implemented. And the last step in this process is when you get decision automation. So this means that a very simple example that most people are familiar with is, well, say we get a lot of traffic to a server. That means that we need to scale up this server. We need to make it a bigger, better server. And this is what Azure basically does, or what Azure can do. You can set some rules that say, well, when we see this much CPU usage, you must scale up the CPU. You must go to another tier in this virtual machine or database, for example. And that's basically decision automation. You don't need to do anything. All your decisions get automated. The entire domain of predicting and making decision automation, that's basically data science. And this is how you go from data to action in the fastest way possible. Well, the thing is, not everybody can start making a data science project. Not everybody can just put up a predictive experiment or even implement data decision automation in their company. Most people just have data and they create some reports. This is just classic BI. IT makes a report for the end user, and that's it. That's where things stop most of the time. If you want the report changed, you have to go back to IT, and they might make it again for you, or they might make the changes for you. But the thing is, Microsoft also underwent this process. Basically, when Bill Gates was the CEO, Bill Gates was an engineer. And this is a story that Amir Nets, a technical fellow at Microsoft, has told well, several times, I suppose. I saw it the first time last year, and around May, in a YouTube video. If you're on YouTube now, search Age of Data Culture, and you should see Amir Net's talk. But back to the point. Bill Gates was an engineer. The BI team had to make products that worked for engineers. That's classic BI. When Steve Ballmer became CEO, Steve Ballmer wasn't an engineer. Steve Ballmer was a business person. And when Steve Ballmer had to make a decision, he had to speak to an analyst, and that analyst had to get data and tell Steve Ballmer what the data was, what decisions he could make, etc. That brings us to the age of self-service BI. The analyst talks to the end user. In that period, Microsoft made tools that made the life for analysts a lot easier. They still made tools for IT, but the focus was on analysts. Analysts talk to end users, they create reports for the end user. If the end user has a question, they talk to the analyst. A while ago, as everybody knows, Satya Nadella became CEO of Microsoft, and the shift, the focus made a shift from providing services to IT and analysts to providing services to everybody. So everybody had to be able to make reports, had to be able to get data and to get insights and take action from the data. But it's very dangerous to just put data in everybody's hands. It's not as easy either, because not everybody has the knowledge to work with, for example, analysis services or reporting services. Some people just want their Excel, and that's it. So Microsoft came up with Power BI. It underwent a process of development, but August last year, I believe it was, when the Power BI version 2.0 was released officially. It was just, well, it was the best tool there is. Basically, it still is the best tool there is. It was voted the best tool by PC Magazine just last week, I think it was, or 2 weeks ago. This showcases what effort has been put by Microsoft into Power BI. But this isn't enough for most corporate environments. In most corporate environments, you can't just give all the data to all the users. You still have IT that needs to do things. You still have security. You still have processes that needs to be followed. So what do we do? What can we do to get BI and even data science to a regular user? Well, the thing is, we have corporate goals that we need to follow, that we need to keep in mind. There are a lot of processes that we have to follow. The processes, they tend to range from making changes in the data center. They go from even changing a font on the report. That means following a process, getting a change, getting signatures, getting acknowledgements, going through the entire development and testing and acceptance and production stages. You can't just put a tool into people's hands and, well, pray that they make the right decisions from the right data. You have security as well. Security is probably one of the biggest goals in a corporate environment. Data is very precious, and giving everybody access to all the data in the company isn't something that you just do. So think of your own company that you work with, your own corporate environment, or somewhere that you have been in the past year. Think, when you wanted to make a change, how many hoops did they have you jump through? how easy was it to build a report and get it deployed? Most of the time, you bump into certain roadblocks, and those roadblocks are processes, security. So what does a corporate solution look like? Usually, it's the classic BI. It's a solution created by IT. It's established. It has an established corporate context. So all the processes, all the security, they are established and they never go away. And the solutions, they are reusable, scalable, and they are even backed up. Something that's not always done when you have what people think is personal BI, with a lot of Excel sheets everywhere. So this is a corporate solution, but what does it mean for corporate business intelligence? Corporate business intelligence, usually you start out building a data warehouse, perhaps some initial reports that warranted the cost for setting up the data warehouse. But after that, every time some user has a new question, every time some user wants a new insight in the same report or wants a new report, they have to go through this huge pile of forms. And they're not always printed, they're not always physical these days, but they're at least digital. And people working in larger corporate environments, they know this. They know that if I want an extra column in my report, if I want an extra graph, if I want this graph name changed, I have to fill in paperwork, I have to submit it, I have to get they have to get approved, etc., etc. So not everybody is in line with making things easy for everybody. So this is the same for corporate data science. Kimberly, who has experience with data science projects, she was able to tell me that when you have a data science project, you start with a question. You start with that business question for knowing which customers will churn in the next month, which customers will leave our company. But this question needs a lot of deep analysis, and it requires that a predictive model is constructed. But before we can do that in a corporate environment, we have to jump through the same paperwork, and the paperwork goes so far that it can take up to a year before the data science project is actually started, before you even get to working on a data science project. So this means that even after you got that approval, your data science project isn't finished yet. You just started it. So this isn't really ideal. And it also means that when you work in a corporate environment, in a data science project, you need different people. And getting those different people, getting those different skills, also requires a lot of time. So this means that in data science, the skills that you need are different than a regular BI project. A popular picture that's often associated with data science is a Venn diagram by Drew Conway. So it basically says that you need mathematics and statistical knowledge. And not only do you need mathematical and statistical knowledge to do a data science project, you also need domain expertise. So you need to know what you're talking about. You need to know what makes customers churn, what makes customers leave our company. But apart from that domain expertise and mathematical and statistical knowledge, which builds a traditional research background, basically, You also need something which Drew Conway called hacking skills. And these hacking skills, it's a term I don't agree with, but basically it means you need to be able to program. You need to understand computer science a bit. You need to be able to create your own models. You need to be you need to be able to deploy things. But when you have only certain parts of this Venn diagram, you either fall in the earlier mentioned traditional research, when you only have domain expertise and mathematical knowledge, or when you have the programming ability and you have the mathematical knowledge, you fall in a pure machine learning domain. You can do machine learning, but you can't really do data science. And when you have just programming skills and you have the domain expertise, you know what you're talking about. That's basically what they call the danger zone. This term, although I find it a bit laughable sometimes, it really is something that we also see it in a regular BI project. When you know how to query something and you know your own domain, well, that means that you can write queries, but you can't be sure that your queries were right. You can even present data to your own advantage. You can say things that aren't true because you want them to be said like that, or you can think things are like that, but they aren't. And that's why you need all those domains. You need to be a data scientist. So these days, not only do people just say, well, you need to be able to do all these things, they say, well, just get a team together that has these 3 skills, so they can just work together and do all those things. And this is where Power BI comes into play again. A regular data scientist, when they work a full week, let's say 40 hours, they need to do ETL. They need to get the data. They need to extract data from the source. They need to make transformations on the data. And then they need to load data into another source so they can do analysis. That ETL process can take up to 4 hours per week for a data scientist. But they also need to do data cleaning because not all data is correct. You can have blank values, you can have incorrect values. So they need to clean the data. And that can take up to 15 hours a week. So that's almost half a work week already gone. And after that, they need to do an exploratory data analysis. They need to see, well, how do these features, columns in the data, how do they relate to each other? How do they relate to the data that we imported from that other source? That can take another 15 hours per week. And after that, they can start their real job. They can start what is basically seen as data science. They can do machine learning. And that last part takes up to 15 hours a week as well. These aren't just numbers that we made up. It's an O'Reilly survey that O'Reilly made. I have a link on my blog. You can check it afterwards. But this means that for at least half of the time, a data scientist is doing things that are suboptimal, that aren't very suited for their job. It helps them because they need it, but perhaps we can make somebody else do these parts. Perhaps we can make somebody else do the exploratory data analysis. Because for an exploratory data analysis, you need to have domain knowledge, you need to know what you're talking about, and you need to be able to wield a tool that can explore the data. So this brings us to basically personal BI and data science. In personal BI, we basically get the view of most people that it's a lot of Excel files that everybody are floating around the company, And that is not always the best thing for the company. When you say self-service BI, personal BI, people tend to back off. And when I first uttered the words personal data science or self-service data science, I got some crazy looks as well. So why would we continue with this? Why would you do personal BI, and why would you even go do something as crazy as personal data science? So the personal part basically means the bridge, making the bridge between IT and the user as small as possible. In our case, is the bridge between, in the case of data science, it's the bridge between the data scientist and the user. So the goals that we need to look at is to remove frictions between users and data. How do we basically remove the frictions between the users and the data? Well, we need to become business driven instead of IT driven. We need to bring those two closer together, and that enables us to just make rapid delivery cycles, so be more agile. And while doing this, we also get a bit of less governance of the data. And I put less in quotes because less doesn't mean no governance. It doesn't mean governance isn't important, because it's still very, very important. You can't just have users wielding your data like toys. Data needs to be managed correctly. When we do this, we get freedom for the users. We get users that are able to serve themselves instead of standardized reports that IT made and that take forever to change. So that also means that we don't have to wait for IT to be able to make changes. We don't have to do a lot of paperwork. It's still necessary in a corporate environment to do some paperwork because things need to be documented. And doing this basically brings us to what is a personal solution. A personal solution, or a personal BI solution, is a solution created by the user. And the context for the solution is only for the user, and usually it exists as a document. So this explains the Excel vision that people have, because you have an Excel file that lives on a PC of the user. You have an Excel file that gets sent via mail everywhere, and that isn't viewed as something good. But this isn't what we mean by this. This is just the basis. You still need to manage that solution, but the most important thing is that the context for a solution that the user can create it is only for the user. So how do we do that? Up until now, personal business intelligence basically meant having Excel and sometimes even Power Pivot. Since last year, we also have Power BI in there. Power BI enables users to do almost everything that IT would have been able to do. Power BI enables you to get your data from different sources, from almost any source, from just an SQL database to an OLAP database to even SAP. So just think about that. That's crazy that a user can get data like that from all those sources. And even then, when a user needs to change the data, needs to create new columns or edit certain columns in a certain way, like splitting the month from a date column, they can use Power BI in a very easy way as well. But how does that apply to personal data science? What can Power BI do for personal data science? How do users go about using that? It's not as easy, but they just use Power BI in almost the same way as in a business intelligence solution, but they also can use Azure machine learning. Now, this is something that not every user will be able to do, but they should be able to do that. with some explanation, of course. So let's have a look at how we can apply Power BI to our data science story. The first step in any data science journey, I'll call it, is getting a problem statement. The problem statement basically is the most important thing that you'll have, because without a problem statement, you won't be able to know what you need to predict. You won't be able to know if you have hit your goal even. In our case, we used an example about demand forecasting, about a public biking system in Washington with about 350 stations. And we need to see what are the peaks in demand and supply. Because in the public biking system, bikes go from one location, a station for example, to another location, a station near a busy workplace. And when we have the morning traffic going from the station, the station up to the workplace, there aren't any bikes left in the originating station. So you need to be able to predict what are the peaks, so that we can bring bikes back to the station and fill it up so other people can use it. So how do we optimize the planning of relocating these bikes? That is basically the goal. That is the problem statement that we have. So now we know how to what we need to attain. We can go about getting our data. Getting our data is very easy in Power BI. You just go to the Get Data button. This is a Dutch version of Power BI. Gegevens ophalen that you see in the corner here means get data. You just select a source. In our case, it's a CSV, a comma separated values text file. So we just select the file. But we don't just select this one file. We have several files that we need to combine. We'll get to that later. But when you selected a file, you see this window that displays an example of the data that is in the file. You just press the load button and the data gets imported. But getting the data, as we saw, wasn't just the thing that a data scientist does. We still need to do some data cleaning. We need to enforce our data quality. So if we go a bit further in this example, we imported 4 of those CSV files, which takes a bit of time as they're big files. After that, we can start exploring our data, and we see that in the different files, which cover different quarters of years, so 2014 quarter 3, 2014 quarter 4, etc. We see that there is a difference in the naming of columns. How do we solve that? Well, we need to rename these columns. And renaming a column in Power BI is just as easy as just right-clicking the column and selecting rename column. In my Dutch example, it's naam wijzigen, but yeah, that's Dutch for you. After we've changed the names of the columns, we can view the data, and we can just see what the data looks like. In this data, there's one thing that we need to do, and it is, well, we need to join these tables together. With the tables, I mean the different files that we imported. So we see that we need to join them. Joining them, it's a bit different than just importing. We need to edit the queries. And after that, in our case, we duplicated the first query, which imported the first file. And to just go about let me rephrase it. We duplicated the first file so we can add the next files to it and still have our base data. We still have the data from which we started. To make it clear that we have created a new query, a new data source which contains all the data, we rename this data set to total demand. With every step that we undertake, we can see that step under the applied steps in our Power Query window, because that's basically what this is. Power BI is a combination of Power Query, Power View, etc. So going on to the next step, we need to add queries to the current query. So when we click the button, we can select other queries that we have already imported, and we can just add them. We see here on the right that we added the queries for the other quarters to this first query that we duplicated. After that, we need to just split the date column, the date time column, into something that we can actually use for forecasting, because when we approached this problem and we set the problem statement, we had to we said that we had to predict public biking usage for a day level. In our case, we see that the date time column is a date time. We can't predict date usage when we're working with a date column. That's when we're working with date time column. That's something that Kimberly taught me. So we just split the columns, which is as easy as pressing a button in Power BI. And we can even define what we need to split on. Power BI has different standard options, like splitting on a space, splitting on a comma, splitting on a semicolon, or even just set your own split sign. We select that we want to split on a space. We just wait a bit while the query loads. And after that, we can start our exploratory data analysis. This means we can start building graphs and we start doing the fun part. So we just apply this query, it loads, and we can start exploring. Exploring our data basically means just adding graphs and adding data to those graphs. In Power BI, it works like pressing a button on one of the graphs that you see in the visualization window. Next, we can just drag our data that we want to see on an axis or in the values or in the legend to the right parts for that visualization. In our case, we created a line diagram with the data that we had. But this isn't where it stops. You can even import custom visualizations. So as most of the people already know right now, there exists a website, visuals.powerbi.com, which contains a lot of data visualizations that Microsoft made, but also that the community made. And these different visualizations, you can just download them and import them into your Power BI desktop client, so to the program that we're using. So we have this nice line diagram. We want to make it a bit nicer to help us explore data, because filtering this data isn't as easy as it seems. We can select filters that say from March to May, but we still have to put a lot of work into selecting those filters, and nobody likes a lot of work. So we import a custom visualization that enables us to just do this. We can use the filter at the bottom to make a selection on the visualization, and it filters the data automatically. So the next step basically is we want to see, is our data how does it repeat? Because we see certain patterns in our data. We want to know, is it on a weekly basis perhaps? So we had a visualization that shows us the weeks. And we see that there's different parts in the data. For example, the first weeks of the year, there aren't a lot of bikes rented at that point in time. And also in the last weeks of the year, not a lot of bikes are rented. So this means that perhaps people don't like the cold as much. After we did that, we want to dig a bit deeper into the data, because just slicing the data by a day or by a week is not enough in our case. So we start feature engineering. Feature engineering basically means just adding columns that add value to your data set. And that value is gained from just seeing things up to having your predictive model be able to do better predictions with those extra columns that you created, those extra features. In our case, we want to split the date field into day of week, because we know there's less demand in the cold weeks of the year. But is the demand the same during the entire week? No. Perhaps certain days of the week have less usage. So in Power BI, creating a field that has the day of the week just means selecting the date button, saying you want to create something with the day, and then you have different options. You can just say, well, I want to know the day of the week, the day of the year, start of the day, start of the end of the day. You have a lot of options. In our case, day of the week is the one that we want. And we see a new column appearing that contains the number of the day of the week. So this number means that we can just start predicting. But, well, we can guess weekends perhaps see less usage in the biking system. So perhaps you can create another feature that says if something is a day of the week or a weekend day. In Power BI, this means that we just need to add a new column. But we say, instead of just having the date split into something new, we enter a formula. And this formula can be as easy as you see here. If the field day of week equals 0, or the day of week equals 6, so Saturday and Sunday, then it's a weekend. You need to put weekend into this new field. Else, just put week into the new field. And after that, we create a new visualization containing these data. But we also created another field that contains if somebody is a casual member, or if it's registered, or whatever. Anything that can help us explore the data, we need to put that in our Power BI report. So that means that we also perhaps want to see the day of the week field that we created. In our case, we just add a tree map, because that can help us show great differences between certain days. We see here that perhaps the difference isn't as big as we thought, but Saturday and Sunday, positioned at the bottom right, does have a bit less people riding the bikes. So what's next? We created some visuals that we can slice and dice the information on, the data that we have. Well, perhaps we want to add different data. We know during those quiet periods that we see at the beginning and the end of the year, it's winter. Does winter, or the weather more in general, have something to do with these slow weeks that we have? Well, we can just add some weather data. We go again into the edit query windows, the query editor, which is something that you will play a lot with in the Power BI desktop client when you're just creating a new report. In our case, we download data from not only the weather, but also holidays, because, well, perhaps holidays have something to do with that as well. So here we see we added the weather data, the public holiday data, and next thing we need to do is just, well, we need to join these new data fields, these new data sets that we created to our current data, because loose like that, well, they can be joined, but not always in all cases. Just add data. Adding data is just as simple as, perhaps I went a bit too fast, as clicking the query merge query button, selecting the data set that you want to merge, selecting the field that you want to merge on, and selecting the type of the join that you want to create. Most of the time, you just want to do a left join. But of course, it depends on your situation. When we've selected the column that we want to join on, next up is selecting which columns we want to display after we join the data. In our case, we only have 2 columns, and we only want the holiday name to be displayed. So we select holiday name, and we go further back into our data to make another exploration. In our case, we created a word cloud, one of the custom visualizations that you can download. And we see that, well, summer, spring are very busy periods. In these periods, there are a lot of people renting bikes. And in winter and in the Easter period, Veterans Day, there are a lot of less people renting bikes. So what's up next? We have the weather data. We still have the weather data. For the weather data, to explore it, we create a new report because our previous was already filled, and we just plot all the data together. This is something that not everybody will understand, not every end user will understand it, but you can see patterns in this data. I saw patterns in this data, and I'm not a data scientist. I see that for the temperature, there is a rise in the demand. So the colder it gets, the less bikes there are. The hotter it gets, the more bikes are rented. So does this keep going? Now we see a fall off at the end. We see that when it's too hot, less bikes are rented. So does this mean there's a pattern? Yeah, of course there's a pattern there. Nobody wants to rent a bike when it's too hot. You just get all sweaty. And when it's too cold, you might slip and fall. But what about the rainfall? When it rains, do people still want to rent bikes? At first, when I saw this data, it looked like, well, yeah, people are still renting bikes. On the y-axis, we see that a lot of bikes are rented. And on the x-axis, we see the rainfall. And up to a certain point, people are still just renting bikes. But we have these outliers in the data. What does it all mean? So this is basically the point that an end user should go talk again with the data scientist or the analyst, because personal data science only goes so far. And in our case, well, we can be sure that there really is a pattern here. We can just do our best, and that's about it. So that brings us to forming a hypothesis. Forming a hypothesis basically means saying in what cases is there a high demand, in what cases is there a low demand. That's the simplest explanation that I can give it. Kimberly would probably look very angry at me at this point, but yeah, that's basically what it is. You make a theory and you see if it's correct. In our case, we started looking at patterns of data per station because stations in busy areas, they are visited more often, and stations in not so busy locations and quiet locations aren't visited so often. At least that's what we think. And looking at the data, creating different visualizations and filtering them on different stations, we see that the different stations get different usage, but also different usage patterns. We see that the station at the top, we see that it has a high usage almost all year with small swings. And during the winter months, we see a bit of less usage. The second station on the slide, we see that there are a lot of high and low spikes all the year round, with the lowest spikes, with the lowest changes during the winter months. And the third station, the third graph that's here, the third station, has a very low usage almost all year round. So not going very deep into how we do that. Basically, when you see different kind of patterns, or when you think there are different patterns and you think you see them, you go back to your analyst or your data scientist and you ask them, oh, are they really there? Is this really so? They do something that is called k-means clustering. So they get a clustering algorithm. They get some R code or something else in Azure Machine Learning, and they create a model that combines stations with similar patterns, so that you go from more than 350 stations, in our case, to 4 different types of stations. For more experienced users, they can also create these Azure Machine Learning models themselves as well. They can create their own clustering and just go further and further into that analysis of the data. So as I said, in our case, we noticed 4 different clusters, 4 different patterns per over all the stations. And here we see the different patterns. We see the spikes during during almost all of the year, but less high spikes during the winter months. We see in this case that there are low usage all year round, and this goes on for the other stations. But that brings us to our machine learning. Machine learning is not something that really is for the end user. That's really for the data scientist, as I said earlier. That really is the hard part of data science. It's not easy to do. It's not easy to do correct. So just leave it to them. But the thing where end users come into play again, which brings us back to the personal data science part, is monitoring the model. You get data that says, we predict this, and then you see what the real usage was. So in our case, the models predicted the blue lines. The blue lines say, well, this was the usages like this. And when we see that the predicted line goes too far off from the actual line, we know that we have to go to the data scientist again and tell them something has changed. You need to make the machine learning model again. And doing that is something that you can automate if your environment is advanced enough. But in most companies, it still isn't at that stage. Most companies still have the things where they need to do monitoring manually. So this is where end users can provide a lot of value, because you offload that work from a data scientist to the end user, and end users get involved a lot more. So you get a personal data science feeling again. So you can see in our example for June 14th up until almost the end of June, there isn't a huge difference between the predicted and the actual value. But at the end of June, we see a huge difference between the predicted and the actual values. You can even go further with this and set KPIs and target lines. So if you notice that there certain targets are hit or not hit, the end user has it even easier to just alarm the data scientist. So that basically concludes the session. What do I want you to take away from the session? It's that it's not BI versus data scientist. Business intelligence is the basis for data science, and data science builds further upon what business intelligence basically made. It's also just personal BI and personal data science are things that are actually possible, but you need to implement them in the correct way. You need to have an open mind. You need to be able to say, well, the end user can really do this, but you still need to have the process into place, which defines boundaries and which defines which tasks go where. And most importantly, Power BI is such a huge and incredible tool which keeps getting improved every week and every month. So just start using it, start implementing it. And yeah, that's about it. I have several other slides, basically from the data culture Power BI session in London. Some resources. The Power BI community is, well, something that I didn't think Microsoft would do. It's a public forum where you can get help, where you can help others, where you can vote ideas. So if you have an idea that you want to see implemented in Power BI, and you think, well, other people will use this as well, will benefit as well, you can just create an idea and have people vote on it. And we've already seen it. I've already had it myself, where I voted on an idea that somebody else created, and Microsoft picked it up. The product team just responds with, well, we're working on this, or we're thinking about it, we're planning it, and they even say, well, this is a next release, this is coming. The Power BI support pages are something incredible again. They're really geared towards having you be able to do everything yourself, and towards informing you about all the possibilities in Power BI. And last but not least, you have the Power BI YouTube channel. The official Power BI YouTube channel includes all the videos that get released with updates. It includes a lot of tutorials, some commercial videos as well. And those three combined really are something that you need to get involved with, especially the community. Right now, you're watching a Power BI global user group video, which is part of the Microsoft Power BI community. So that's just incredible that Microsoft has done that. And also, as I said before, you have the custom visualizations. You can just go and download and use visualizations created by others. You can even create your own visualizations. And they're very easy to use. It basically comes down to downloading a visual, uploading it into Power BI with the three dots, and start using them. For me, that concludes my slides. I'm going to check if there are any questions. So let me see. Josh Carlisle. Oh, what's happening? Okay. Josh Carlisle asked if Power BI widget support connect to OneDrive. And if you need to use a long or a shortened URL. Well, George, basically you can use OneDrive in Power BI. It's possible to use it as a data source as well, just as Google Drive, for example. I don't know about the shortened URL, but I suggest you check out the Power BI community website, the resources. Had that slide. Let me go back to them. So just check out the Power BI support page, and the answer should be there. If I think Damodaran Venkatsan asked if I think learning R is a must for personal data science. I didn't showcase it in these slides because personal data science in my book means the end user can do what they want without having to learn too much. As most people already know, there is a preview of R integration in Power BI right now, in Power BI desktop client. The preview has importing data from a data source using R, but also creating visuals, so visualizations with R. It helps, it makes it possible to go further into creating visualizations, but you don't need to learn R to use Power BI. If you run into examples where you work closely with a data scientist, learning R is a must. It's not a must in every scenario. So, for example, I showcased having the user doing an exploratory data analysis and helping with monitoring. You don't need to know R for that. So I don't think R is a must for personal data science. George Carlyle pointed out a typo. Washington was typed as Washington. George, the session should end now. I can continue if anybody wants with perhaps a simple R example. Or I suggest we pick it up in another video as this will be published to YouTube. How to ensure permissions are set correctly in Office 365 before I just start letting users have free access to the organization's data. That's another question by George Carlyle. It's a very good question because you don't want everybody to get access to all data. So security starts at the data source. The data source needs to have correct security set, of course. In most cases, you'll want to have a data warehouse somewhere, or a tabular model, or a multidimensional model that, let me do that away. You'll want to have one of those other data sources that aggregate the data and makes it usable for the end user. You don't want the end user or any Power BI user, just go into your OLTP system, your live database where all the programs are working on. You want them to work from a reporting source, one that can be queried as much as they want, or almost as much as they want. So start with that, just set security on the source, build a data warehouse, give users access to the data warehouse, or go from there. Another thing is in Office 365, or just, it's Office 365, you can set security that people cannot use Power BI with the organization email. So it's an option that you just disable that until you get your security in place. I hope that answered your question of not letting users have free access to the organization's data. Okay. I see a lot of questions as the presentation started. I suppose that was at the beginning. Okay, that's about it. I suppose I don't see any new questions. Thanks for attending, everybody, and have a great day, or morning or evening, wherever you are.